ladies and gentlemen. Now, we will start our second lecture for the Minitab Assistant. To access the graphical analysis using Minitab Assistant, choose Assistant, then Graphical Analysis, and the most prominent thing you'll see is a question: what is your objective? But you're not left with just the three objectives. Select Graph the distribution of data, and before you have to pick one of the 7 possible charts, the assistant offers to help you choose. Here is a map helping you to choose the suitable distribution for your data. However, if you select graph variables over time, and before you have to pick one of the 6 possible charts, the assistant offers to help you choose. Clicking Help Me Choose takes you to a full flow chart that reveals important considerations in choosing which chart to make. Each decision point on an assistant flowchart is clickable, so if you click Data Collected in Subgroups, you get helpful content, with an example, to help you decide whether you have subgroups or not. Click Back to go back to the entire flowchart. So, if you click Display Control Limits, you get helpful content, including an example, to help you decide whether you want to display control limits or not. Again, click Back to go back to the entire flowchart. If you click What do you want to evaluate, you get helpful content to help you decide, what do you want to evaluate. To access the hypothesis tests using Minitab Assistant, click Assistant then click Hypothesis Tests in Minitab. Up comes this dialog box. Well, if you know that you have 2 samples that you want to compare, but you can't remember if you need a paired t-test, a % effective, or what, so you will click Help Me Choose. Now the assistant gives you an easy-to-follow decision tree that leads you to the 2-sample t-test. You can follow the tree straight to its conclusion, as shown. But if you can't remember enough specifics to follow the decision tree from start to finish from the amount of information shown, the assistant will actually guide you through the process step by step so you will arrive safely at the right hypothesis test to use. In this scenario, the assistant asks one question, then you choose the right option for your situation and proceed to the next question. Particularly helpful is the fact that if you forget, for example, what are you comparing? All you have to do is click on a button and you'll get an explanation and an example for both, the mean value and standard deviation. Another help to decide, what are you measuring? Click on the button and you'll get the explanation with the example for the independent and dependent items. Or, are you measuring different sets of items? Or the same set of items? To make regression for data using Minitab Assistant, go to Assistant, then click Regression, and you'll see the interactive decision tree. You can click the diamonds for more information about how to choose, including examples of the analysis. Now, we will perform exercise for the multiple regression using Minitab Assistant. As part of a solar energy test, researchers measured the total heat flux. They found that heat flux can be predicted by the position of the focal points. We want to use the new features in the assistant to correctly position the focal points. We have 3 X variables, predictors, and want to fit the regression model and to optimize the response variable. Please download Minitab worksheet heatflux.mtw from the resources and follow the tree in order to optimize response at the bottom right. Please note that we want to target the heat flux value of 234. Please pause the lecture and solve the exercise. Our response variable is heat flux and the X variables are the east, south, and north focal points. We've determined that we want to target the heat flux value of 234, but the assistant can also maximize or minimize the response. We'll also have the assistant help us check for interaction effects and curvature. Click the Optimize Response button. Fill in the dialog that appears with this information and click OK. The assistant takes our candidate X variables and produces a regression model. Let's take a look at the reports that the assistant provides. This summary report tells us that our regression model is statistically significant with a p-value less than 0.001 and has an R-squared value of 96.15%. Great! The comments section indicates which variables were included in the model. In this case, the assistant includes east, south, and north, along with several polynomial terms to model curvature and several interaction terms. The effects report graphically illustrates all of the interaction and main effects that are in the regression model. The lines are curved when the assistant includes a polynomial term to fit a curve. For example, the east-south interaction is significant, which indicates that the effect one variable has on heat flux depends on the setting of the other variable. If south is set at a low setting, 31.84, increasing east reduces the heat flux. However, if south is at a high setting, 40.55, increasing east increases the heat flux. The diagnostic report displays the residuals versus fitted values, and identifies unusual points that we should investigate. Based on the criteria for large residuals, expect roughly 5% of the observations to be flagged as having a large residual. So, the 2 we have are not necessarily problematic. There are also 2 points with unusual X values. We can click the points to see which row they are in the worksheet. The model building report shows the details about how the assistant built the regression model, the regression equation, which variables contribute the most information, and whether the X variables are correlated with each other. North contributes the most information to this model. East is not significant, but the assistant includes it because it is part of a higher order term. The assistant always watches your back. For example, when it builds your model, it uses standardized X variables because standardization removes most of the correlation between linear and higher order terms, which reduces the chance of adding these terms unnecessarily. The final model is displayed in unstandardized, natural, unit. The prediction and optimization report shows the assistant's solutions for obtaining our targeted value of 234. The optimal settings for the focal points are east 34.45, south 36.19. and north 17.24. For these settings, The models predicts a heat flux of the 234 with the prediction interval of 222.6 to 245.4. The assistant also provides alternate solutions for you to consider using your subject area expertise. Finally, the report card prevents us from overlooking issues that could make the results unreliable. For example, we should collect a larger sample size and check the unusual residuals. Normality is not an issue for our data. And there is a reminder that we should perform confirmation runs to validate the optimal values. Please check the Minitab project heatflux.mpx for the complete exercise solution and the resources. To plan and create experiments using Minitab Assistant, go to Assistant, then click DOE, then click Plan and Create. You will be presented with a decision tree that helps you take a sequential approach to the experimentation process by offering a choice between a screening design and a modeling design. A screening design is important if you have a lot of potential factors to consider, and you want to figure out which ones are important. The assistant guides you through the process of testing and analyzing the main effects of 6 to 15 factors, and identifies the factors that have greatest influence on the response. Once you have identified the critical factors, you can use the modeling design. Select this option, and the assistant guides you through testing and analyzing 2 to 5 critical factors, and helps you find optimal settings for your process. As we have been seen before, the assistant gives you the critical information you need to proceed. For example, that you aren't sure what your first step should be. Click Plan the experimentation process, and the assistant reminds you that a good place to start is by making a list of potential factors. The assistant offers 14 screening designs that will cover most of the typical situations you'll encounter. On the flowchart, click Create Screening Design and you're on your way. Fill in all the required data. As soon as you click OK to create your design, the assistant asks whether you want to print a data collection form. If you're entering your data directly into the worksheet, you may not need to print. But if you'll be collecting data manually, for instance, if your experiment happens in a place where you don't have access to your computer, the assistant takes care of spacing, orienting, and titling the form so that you don't have to. Take a look at the difference. The summary report that's printed when you create the design even tells you the effect size you can detect 60% of the time and 80% of the time. This detection ability means that when you choose a design the assistant offers, you can be confident you're planning an experiment that's going to find important effects. The detection ability is an important feature that makes sure that your designed experiment is not a waste of time. The least powerful screening design the assistant offers has an 80% chance of detecting an effect, just a bit larger than 2 standard deviations, a moderate size effect. The rest all have a better than 80% chance of detecting an effect, smaller than 2 standard deviations. For example, for 6 factors and 12 runs, you can detect an effect of 1.68 standard deviations 80% of the time. There's more to successful DOE than knowing how to check your residuals. That's what the pre-experiment checklist is for. The checklist reminds you about important steps that don't necessarily have to be done in Minitab, like making sure people helping to run the experiment agree on how to set the factor levels, and performing trial runs if you have the time and money. View the checklist by clicking the link at the bottom of the report card after you create the design. But the assistant can also help you make sense of the data you collect for your experiment. After you create a design with the assistant, choose Assistant, then click DOE, then Analyze and Interpret, and you are on your way. Exactly what you get depends on which type of design you are analyzing, but there's some really neat stuff to help you get the most out of your data. First, the assistant offers a summary report that gives you the bottom-line results of the analysis. The Pareto chart of effects in the top left shows that cure temp and hard time are statistically significant. The summary report also shows that the model explains very high proportion of the variation in response, with an R-power-2 value of 95%. The assistant's effects report tells you more about the nature of the relationship between the factors in the model and the response, with both interaction plots and main effects plots that illustrate how different experimental settings affect the response. The report card shows if there are unusual data or not, and also the next steps. Thank you. And see you in the last module of our course, the conclusion.